Hi guys and welcome to this video. In this video we will learn the hardware components of PLC or programmable logic controller. So let's get started. The first part is processor or CPU, which is the brain of the PLC. It performs three key functions. First, it processes input signals received from sensors and switches. Second, it executes the control logic program to determine the necessary actions. And third one is sends output signals to activate motors, solenoids and other output devices. For example, in an automated conveyor system, the CPU decides when to start or stop the motor based on sensor inputs. The next PLC component is the power supply unit. The power supply unit keeps everything running. It takes AC power, typically 110 volt or 220 volt, then it converts it into low DC voltage, typically 24 volt, and then it supplies power to the CPU, input and output modules. Without a stable power supply, the entire automation system would fail. The next PLC component is the input module. The input module acts as a bridge between the sensor and the CPU. It receives signal from input devices, for example sensors, switches and flow meters. It then converts them into a format the CPU can understand. For example, a sensor detects an object on a conveyor. The input module sends this data to the CPU, which then decides whether to activate an output. The next PLC component is the output module. Once the CPU makes a decision, the output module sends signal to control devices, for example motors, for moving conveyors or robotic arms, solenoid valves to control fluid or airflow, relays and actuators to switch circuits and perform mechanical actions. The next component is programming device. To control a PLC, we need a programming device. This can be a computer or a dedicated handheld PLC programmer. This device allows engineers to create, edit, and upload control logic into the CPU. Once the program is loaded, the PLC can execute automation tasks. The next component is memory unit. The memory unit plays a crucial role by storing the PLC program, holding input and output data, and ensuring smooth execution of control logic. Without memory, the PLC would not retain its program or process input correctly. And finally, we have communication interface. In modern automation, PLCs communicate with other devices using the communication interface. This allows data exchange between PLCs and external systems, remote monitoring and control, and synchronization of multiple PLCs. This is essential for large-scale industrial automation and Industry 4.0 applications. So that's an overview of PLC hardware components. If you find this video helpful, then please hit the like button and subscribe to my channel. Thanks for watching.